Good morning, students. Today I am explaining model number to continue the first comparison between NR method and Gauss Seidel method for load flow analysis. Okay, what is NR method? The Newton-Raphson method require less number of iteration, less number of iteration, less number of iteration. That is regular less number of iteration to the reach can be conversions. They require large number of iterations to reach the conversions. The NR method, the complex method, anyway, less number of iterations. In Gauss Seidel method, large number of iterations to reach a conversion. The computation time per iteration is more because of the complex. The calculation is more, the iteration also more. But here, calculation is less, iteration is less. Calculation of iteration. It has quartic equation conversion characteristics. It has a linear conversions. NR Gauss did a linear conversion in NR method quartic equations. On our independent, the number of iterations are independent to size of the system. But here the number of iterations required conversion with the size of the system. More memory required. Because the complex method is a more memory required. It's a less memory requirement. Next, FDLF method. Jacobian FDLF method, the start with the J11, J12, J21, J22. Just to calculate J11 element, J12, J21, J22 with respect to all Jacobian matrix. Dou Px, dou delta with respect to angle, this respect to voltage, this respect to angle, this voltage with the real and reactive power. The elements of J elements, the Jacobian matrix 1, 1, 2, 2, 2, where dpi, dqgi, dvk, these are the equations, standard equations, just to derive the equations to calculate real and reactive power. With the flowcharts, the start read with the load flow data, the Y bus, first to calculate Y bus, next you identify the slack bus, next PQ bus, PV bus. Here slack bus with the reference bus, PQ is a load bus, PV is generator bus. Next the B11, B1 dash matrices. You calculate in Jacobian matrix, you separate B11, B11 dash. Set the iteration count 0, that is RV, the R delta, the voltage and delta angle. Calculate delta PI, I equal to 2, generator voltage, load bus voltage. Next to solve the angle and voltage. Is the tap changing transformer, here ABC, here the load with respect to the star connection. Transformer provide the convenient means the controlling the real power and reactive power flowing with the transmission line. Here real and reactive power flowing along with the transmission line. You calculate real power is controlled by means of shifting the phase shifting. By the phase shifting, the voltage will be increasing, reactive power will be changing the magnitude. The voltage magnitude can be changed by the transformer provided with the tap changing under TLCUL under the load. Transformer are especially designed to the adjust the voltage. Why they adjust the voltage? Because the voltage will be increasing the secondary side. The phase angle through small value are called regulating the transformer. Regulating means you voltage will be constant. Regulate the transformer. The regulating the transformer for control the voltage magnitude, which is achieved by adding in boosting the voltage. Why the boosting voltage? Because the reactive power will be injected, voltage will be increasing, voltage will be regulating means constant voltage in secondary side. The regulating the transformer which shift the voltage phase angle, which is no perceivable change, is magnitude. Next, voltage profile controlled is the last concept of the second model, voltage control profile, adjusting the generator excitations. But here the initially generator voltage input, here the respect to generator real and reactive power, this is a load side, the demand and the load side. At bus with the generation of the voltage can be conveniently controlled by adjusting the generator excitation. By the excitation, voltage level will be increasing secondary side. Here P, that is V, and EGI, XGI, that is with respect to the angle sin GI and dou GI and load. Real and reactive power with the generator, we calculate PGI, QGI. The same thing control of ER voltage, generator reactive. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3 Some of the load bus voltage work out to be less than specified power voltage limit indicate that the reactive power flow capacity of transmission line are specified, resulting limits with constant meet reactive power the load demand. This situation can be rem- uh, re- uh, remedied by installing VR generator. There are bus voltage flow analysis solution giving the requisite value of VR. Control of VR generator. Next to control of. Next, what are the assumption made the fast decoupled FDLF method? What are the assumptions? Assumption means assumption which are the valid normal operations are made as follows. Cos of the angle, next time active reactive power angle will calculate assumption with the H and L. H and L matrices become considerable simplified or given by this. You calculate H and L with angle, real power and voltage, reactive power and voltage, bus voltage and reactive bus voltage. The matrix form we get, you calculate P and Q value. Both the B1, B2 dash are real line structure of H and L will be calculated. Thank you. The remaining next video lecture.